Have you ever wondered what the real efficiency difference is between the 19 and 21-inch wheels on a Model S Plaid? Do the Aero wheels impact performance? If you're like me, you've watched many other videos on YouTube only to find speculation and anecdotal references. So today, you're going to learn some of the behind-the-scenes info of the automotive industry that will help us identify the exact differences between these wheels. If you're interested to learn how things really work, stick around. Hey guys, welcome back to the channel. I want to take a second to thank all of you for your support. At the time of this recording, I've passed 300 subscribers. This is incredible. I will do my best to keep up with the comments. I'm getting lots of great feedback so far and a few good ideas for future content. Thanks for helping get this channel off the ground, and your support really means a lot. Remember, every like, subscribe, and comment helps out. Today, I'm going to let you guys in on a secret. Because of the fuel economy regulations, the EPA has created a database with tons of information about the vehicle's fuel economy certifications. All this information is accessible and free to download from their website. It really is a treasure trove of information. But at this point, you may be asking, what does fuel economy data have to do with the wheel size on an electric car? Let's start from the beginning, and I promise this will all make sense. In the United States, automotive manufacturers need to produce vehicles that meet emissions regulations, and one aspect they're measured on is the average fuel economy of all the vehicles they sell. You may have heard of CAFE, which is Corporate Average Fuel Economy. This means the OEM can produce a mix of relatively efficient vehicles with some higher polluting cars. But if they don't achieve their target average, they're subject to financial penalties. The fines for missing this target can be huge, so the automotive companies spend lots of money optimizing their cars and also how they test to maximize their fleet average. We will be focusing on one aspect of how they maximize their fuel economy average: accurate road load measurement. The road load is a combination of the rolling resistance of the tires plus aerodynamic drag. This value is put into the chassis dynamometer to simulate the resistance the vehicle would see on the road as the vehicle runs through the fuel economy cycle tests. If the OEMs overestimate the road load, their fuel economy test result will be worse than it should, possibly causing them to miss their corporate average, leading to fines. And if the OEMs underestimate this value, it can be considered cheating, and again, more fines. Hyundai learned this the hard way back in 2012 when it got caught cheating by underestimating the road load and had to pay a $100 million fine. All of this to emphasize that the accuracy of the road load information the EPA has is as accurate as OEMs can make it. Now for the electric vehicle part. These same tests that measure fuel economy for internal combustion engines are also used to measure range for an electric car. Our focus today is on the key efficiency benefits of the Aero wheel compared to the 21-inch wheels on the Model S Plaid. One quick disclaimer, I have not been able to find or locate any data for the polar moment of inertia for these wheels, so that effect will not be included today. If you know of anywhere I can find these details, please let me know and I can do a follow-up video. Now, let's start putting that really good EPA data to use. We will get the 2021 dataset from the EPA website. Look for the Tesla Plaid. Looks like they have both the 19-inch and 21-inch data sets. The other really good news is that these vehicles are identical except for the different wheels, allowing us to isolate the wheel difference. Now, in the data set, they don't have only one number for road load, they have three different numbers, an A, B, and C coefficient. And this is how we will define the road load force curve. Let's look at the road load force curve first to understand what we're going to calculate. The y-axis is the road load, and the x-axis is the vehicle speed. As you would expect, as vehicle speed increases, so does the road load. It's not linear, it increases at an exponential rate. This is mostly due to the aerodynamic drag equation that has a velocity squared term, but we won't get into that. You can also see there's an offset at 0 miles per hour. This is how much force it takes to keep the car moving at really low speeds. Next, we can take the EPA data and put it into the equation to calculate road load force at any speed. Unfortunately, the units aren't in metric, a pet peeve of mine, but I'll survive. So let's take the A, B, and C coefficients and multiply them by the velocity we're calculating for. In this case, I'll be using the 21-inch Plaid coefficients and 50 miles per hour, as this is the reference speed that the EPA uses, and it will also allow us to double check our work. The result is 96 pound force, which is also 428 newtons. This means that 50 miles per hour, the force trying to slow the vehicle is 96 pound force. While the force is helpful, let's make this a little more meaningful and put it it into horsepower. We will calculate how much power it takes to maintain a constant 50 miles per hour. We take our velocity, 50 miles per hour, convert it into feet per second. That gets us 73.3. Plug in the numbers. We get 73.3 times the road load force of 96 pounds and divide by 550. And the result, 12.8 horsepower. That's it. Just 12.8 to keep a Plaid Model S going 50 miles per hour. Maybe 1,000 horsepower is a little overkill. As mentioned before, in the EPA data, they have a certification summary information report, and it also shows 12.8 horsepower. It looks like our calculations are correct. Now let's use those equations and create some graphs. I've taken those equations and the A, B, and C coefficients for the 19 and 21 inch Plaid and plotted them into some charts so we can see the difference. This first graph shows the force difference up to 80 miles per hour, which is the maximum speed these coefficients are validated to, and then we can take those values and create horsepower graphs. As you can see, at 50 miles per hour, the 21 inch wheels take 12.8 horsepower, as we calculated before, and the 19 inch wheels take only 11.4 horsepower. This is an 11% reduction compared to the 21 inch wheels, but in absolute terms, it's only 1.4 horsepower. Now let's have some fun and extrapolate these curves up to 200 miles per hour. You can see that this takes us up to around 300 horsepower of road load. That's not bad for this kind of speed. However, the differences between these lines are a little hard to see, so I made a few additional graphs for us to look at. This graph will help us understand the efficiency benefit from the 19-inch wheels, showing the percentage reduction in road load compared to the 21-inch wheels. This is what the Tesla engineering team was designing for: 10, 15, 20% improvements at the speeds used in electric vehicle range tests. Keep in mind, during the range testing, the vehicle is not using much power from the electric motors, so small improvements in road load will give large range benefits. This is certainly a major contributing factor for the two different range ratings between the wheels. However, if we then look at this from the perspective of acceleration performance, I have plotted the horsepower difference between these two wheels. What is immediately obvious is that the difference is quite small. It's 2 horsepower at 70 miles per hour and still only 7.5 horsepower at 150 miles per hour. Compared to the 1,000 horsepower from the motors, the benefit from the aerodynamics and low rolling resistance tires is negligible. I suspect if there's any acceleration differences between the two different wheel sizes, it is purely due to the lower wheel inertia. If I can find out that info, I will share that with you in a future video. For now, this is a convincing argument that the 19-inch Aero wheels are going to be good for range, but not going to help performance. Thanks for watching. Please don't forget to leave a comment down below.